Hi everyone. So in this tutorial we will explore filter in Spark, right? So filter is one of the common operations. So filter as usual, right? We will go and check the source code or the API signature. So if we go and check the API signature, it is saying it will take column or name. And if you have watched my earlier video, column or name means it can take either argument which will be of type column or a name which is nothing but a string, right? So the same has been given here. So if you see here, this is the typing of Spark, and here if you type a column or name, if you see, right, like there is a union. So this means it can either take a column type, so or it can take a string, right? So now since and the other explanation which has been, or the other thing which is given here, is a column of type boolean type, right? So what is that means, column of type boolean type, right? So for that, right, we need to go and check the column type source code. So this is the column type source code or the API documentation. So here we need to handpick the methods, right? What and all will give a boolean type, right? So few of the things you can guess from the column or the SQL style of things, right? So like, right? So like or I like, right? Null, not null. If you see, right, these are some of the things which are returning a boolean, right? Like true or false. Boolean is nothing but true or false, right? So now I would like to touch upon few of the key things, right? So how will we filter, right? Say number one is we will need to filter null and not null, right? And some constant values we have to do, right? And finally, we can also do the same using our normal SQL query, right? Like say how we write in SQL, right? Where ID is equal to 10, like that, right? So for this purpose of video, right, let us take these four columns, right? So we have four columns basically, right? Age, name, place, and join date, right? So join date has been added, right, to show that like it will work with date as well. And we have made it the necessary imports, right, like functions imports, and then date time from Python module for filtering based on date. So this is the sample data frame. You have age, name, right, place, and join date, right? And couple of things I want you to note down is there are some null values and there are some blank values as well, and there are some future dates as well. So let's see how we can clean up these things as we go through this, right? So the first filter type is simple filter, right? So simple filter means we are just checking based on equal to, right? Say for example age equal to 2, right? So if you see here, in terms of string, right, it is simple, right? Like a SQL query we are doing it, right? But in terms of the column API, right, or in the data frame construct, right, we have something known as equal null safe, right? So let's go and see what is this equal null safe. So if we go and check the column documentation, we have this equal null safe, right? So what it will give is, see, it will take some column. Basically it will take an input column and it will return back something like an again a column, right? So the condition for us to satisfy is any like a filter condition will take anything which returns a column type, right? So this is also returning column type. And what are the arguments it can take? It can take a column or a literal type or a date time literal, right? So what we are trying to do here is, here we are basically trying to add a, so let's see, right, what is date time literal, right? If you go and see this one, so we should have the date time literal. So date time literal is nothing but it is of type either date time dot time we can use to filter, or we can have a literal which is a primitive type. So primitive type is nothing but your int string, right? Whatever we have in our basic primitives, right? So if I go and check for primitive type, right? So let me check primitive type. So again we have this primitive type, which are like basic strings. Now let us go and see, right? Now since it accepts all these, right, if you see here, we have given equal to 2, right? So it goes and filter equal to 2. And since it can also accept other primitives, right, we can also see it accepts 2, right, which is just number 2, right? And with number 2 as well you will see the filter. And the final one, right, or the more unfamiliar API is that it can also filter for date time. So if I see here, right, I have just filter for 2510 1, right? And you could see the last two rows, right? Like where the date is on 25/10/1, right? It is getting filtered, right? And the second common use case which we will have with filter is basically filter for null values, right? So when you say filter for null values, right, it is simple, right? We have the df dot c, we know it in SQL, right? Df dot filter name is null, right? But in column API we have this f dot column is null, right? So again the API definition basically follow the same. You have to go here to the column data type, check for is null, right? What is that? It will take, so it is nothing but it doesn't takes anything but return backs a column. So it check it, basically falls under our criteria, and it will return true if the expression is null, right? So when we filter for this, it should give me all the rows, right, which are basically null in the name. So both we have achieved, right? So the next filter is we may need to do some partial matching, right? Like we will generally use like operator. So the same like has been there in both SQL format as well as in the data frame API, right? And one variation here which I want to call out is sometimes, right, you will have a like, but you need a case insensitive, right? So for that, you can use this I like operator. So if I see the show you the I like output, right, it will show you both the Delhi, right? Like the Delhi which is in small case and Delhi which is in upper case, both has been in the result set, right? This is because I like will do a search and match based on case insensitivity, right? And the other thing is the use of percentage. This means it can have any number of characters before or after, right? The percentage. The percentage means if you have a percentage at the front, it can take any number of character before, and a percentage after the word means it can take any number of characters after, right? And since we have Delhi here at the start, so both will be like if you use either percentage at the beginning or if you omit percentage at the beginning, both will work. Why? Because both are meaning the same, right? Like we just have Delhi, right, and we don't have any characters at the front, so this should work, right? So this is like. And the next thing is we have a between, right? So in SQL it is simple, right? You will have the filter like age between, right? But whereas in this one Spark API, you will have a column, right, API of between, right? So again the concept is simple, right? Once you learn this one, you just have to go here, see between API. So what and all it can accept anything which is of literal datetime decimal, right? So for simplicity we are going to just filter based on start and end value, right? And if you see here, we are able to get the values, right? And the hack here is, right, so if you see the documentation, right, they have given anything that is returning boolean, right? So 1 equal to 1, right, which obviously means for every row it will be true, right? So if you see here, I mean, this is not making any sense, but to just show you, right, like that this is also a boolean, right, and 1 equal to 0, right? So this will also will work basically, right? So you can ask me where it will help. So one common use case where I have used this 1 equal to 0 is, let's say I have some 3 4 data frames and then I have to union it, right? So in order to have the, like say if I have to union all the four, right, first I will have this first data frame where 1 equal to 0, and this will fix my mtdf with the schema based on which I will union all the other subset. So this is where this will be helpful, right? And now since we are good at Python, or since PySpark is combination of your Spark plus Python API, let's see how we can leverage that, right? So one common scenario, right, we will use an incremental load, right, where we have to filter based on a start and end date, right, or start time and end time, right? So what we can do is we can store the start and end time in a config table, and we can just filter the new rows, right? Say for example, I have loaded the data till yesterday, and I have to just load only today's data or maybe 1 week data, right? I can have a start and end time. And if you see here, right, this f is nothing but a Python magic string, right? So what does this does this, it will go and basically have your values at the front, meaning, let me do a print, right, so that it will be clear for you guys, right? So if I go and print this one, if you see here, this is getting translated to this expression, right? So join date between 2025 0101, right? So this date time is converted to this format, and you could see that, right, like only these two rows are bit above that range, right? So This is one scenario, right? And we have the SQL expr, right? I think in your previous video, if you have watched it, right, anything like an expression, right, can return a column, right? So one common scenario, right, like you will have a data where you will have null, which is easy to filter, and sometimes you will have blank, which is also something you have to filter out, right? So for that, what we can do is we can do a combination of case statement plus filtering. For example, right, like case one, name is null, or I'm just trimming it so that if you are having single blank or multiple blank spaces, right, everything will be accounted. Then these are unknown, so I just want to filter for unknown, right? So these are invalid. So if you execute this, so this will basically give you your unknown values, right? And next thing is, right, so we want to see till now, right, we have just seen only the positive cases, right? But suppose, right, I want to do the negation, meaning I want to filter which are not unknown, right? Which is what typically we will do. So in normal SQL, it is simple. We can just put a not equal to sign, right? If you see here, right, there is a not equal to. But in case of data frame API, right, if you're a core data frame API guy or a Python guy, you have this tilde operator, right, which is very common in Python. So you just add a tilde in the front, and you do the filter operation, and here you go, right? You will get the filtering, right, which are basically not blank or null, right, in the place, right? And you could see the remaining rows, right? And the last thing is, right, like you have to combine multiple filter conditions, right? Like say I have to combine one select and one filter, or I would say I have to combine multiple conditions, right? Like say place is something and age is within this or something like that. Then I may need an uncondition or an or condition, right? So in data frame API, you can use the ampersand symbol, and in case of R, you can use the pipe symbol. And in SQL, it is straightforward. You can just put R, letter R, or sorry, word R, or word and that will do the filtering, right? So, yeah, this is it, right? So to summarize, right, we explored what is filter API, what is the signature of filter API, and we understood that filter API will take anything of Boolean type, and which will basically of a column of Boolean type. So we need to see in the column source code or column type what and all functions we have which will return a Boolean type, right? And we went to the column source code, and in the column source code we basically went down and we navigated to all the APIs, right, or all the methods which will return true, right? Certain things are directly straightforward, right? If you're from a SQL background, you can like you can use is null, right? And even isin can be used, right? So isin is nothing but it if you want to search for a list of values, right? Say like array of values, right? So this can also be used, right? And what we did is we saw how we can do some data wrangling, right, like for filtering for null values, and then doing a case sensitive and insensitive partial matching, and how to do a range filter in between, right? And we finally saw right, a hack where we can like since it is a boolean, like 1 equal to 0 will be always false, and 1 equal to 1 will be always true. So this can be leveraged during times like when you want to create an empty data frame, or sometimes, right, if you want to do some testing, what you can do is instead of removing this filter block and basically instead of commenting it out and then adding it back, you can just put filter 1 equal to 1, so that every time this all will be written, right? And we see how to add config driven development, right, by adding Python f strings. So this will ensure you that you can load this value, right, like store the data of the last run in your config table, and then from there you can load it back. And the other thing is how we can use the power of SQL expression. Basically, we are adding a case statement and we are trying to instead of adding two more columns, right? Say we have to do coalesce of null, or if like a case statement, and we have to add one more column and then do the filter. But instead of that, this is more straightforward. You can use a case statement and then chain it with equal to condition, right? So this will give you this one, right? And finally, we also saw that negation, right, where you want to negate it between positive and negative values, right, like the reverse set if you want to get, right? And then we also saw how we can combine the expressions, right? Say we can use and ampersand or pipe or and or to basically combine multiple conditions. And since data frame API is based on chaining, right, you can always add, say df.df is a data frame type, and if you go and see df.filter, right, so the filter will be again, it will return a data frame, right? So since this is a data frame, you can also do a select on top, right? So as simple as that, right? So normal data frame has a select expr as one of the method. When you do a filter, it again returns back a new data frame, so that will also accept select expr. That's why, right, this chaining is possible, and then we are returning the final data frame. So I think that's all for this video. If you like this video, please do watch, like and subscribe, and share it with your friends, and do comment out if there are any queries or question, and follow this playlist. There will be more on other basics of Spark as well. Thanks, have a great day.